this video, we're going to talk a little more about all the different phase changes and what's going on between all the different ones. So let's go ahead and get started. This is an example of one kind of phase change diagram. Notice that we're comparing energy and temperature. We have solids, liquids, and gas. We can see as the energy increases, the solids, the liquids, and the gas, the particles spread out. Notice that all of the phases are on the diagonal lines. So as temperature increases in a solid, it eventually reaches the melting or freezing point. And in liquid, as something gets colder, it will eventually start to freeze. The temperature does shift down, but until it reaches that specific temperature, melting or freezing does not take place, which is why the phases are on the diagonal line: solid, liquid, and gas. So we have melting and freezing depending if you're adding temperature and energy or taking it away between a solid and a liquid. And we have vaporization and condensation between a liquid and a gas, depending whether you're adding energy and temperature. So let's try and fill in this blank. As temperature of a substance blank, energy blank. So as temperature of a substance increases, energy also increases. This is a triple point diagram. It's another way to compare solids, liquids, and gases. So solids are always to the left of this first solid line. Liquids are always in the middle of the first between the two solid lines, and gases are always down here in the bottom right. The point they all come together is a triple point, and your critical point is right here. Anything above your critical point is a supercritical fluid, and we'll talk about all those definitions in just a minute. On your triple point diagram, you typically compare temperature and pressure. So as temperature increases, so does pressure. So in order to get to a supercritical fluid, you would have a very high temperature and a very high pressure. Your phase changes could also be present on here. Anything from a solid to a liquid would be melting or freezing. A liquid to a gas would be evaporation and condensation, and solid to gas would be sublimation or deposition, depending if you're adding temperature and pressure or taking it away. So as pressure of a substance increases, temperature also increases. So some key vocab words. Triple point is the temperature and pressure at which solid, liquid, and gas all exist at the same time. It is very specific. Unless all the criteria are met, a triple point will not occur. A critical point is the point at which both the liquid and gas have the same density, and a supercritical fluid is any substance at a temperature and pressure above critical point where distinct liquid and gas phases do not exist. Okay, so those are some key things. I would highly recommend you Google critical point and supercritical fluid just to see videos of them. Now, if you want to find the melting point and boiling point, but the graph is not labeled, you can do this by looking at 1 atm or 101.3 kilopascals of pressure. And melting point and boiling point are always at those specific pressures. So for example, if we wanted to find the melting point or boiling point here, we could go to 1, you draw a line across, and you drop it down. So if we want the melting point, we know the first solid line is from solid to liquid. So here, our temperature would be 0 degrees Celsius. So at 1 atm and 0 degrees Celsius would be our melting point. If we want the boiling point, we're still at 1. This time we're going from liquid to gas. We can drop it down, and it's 100 degrees Celsius. Now, this time you may say, hey, won't it all be the same? No, every substance has a different melting and boiling point, so everybody's triple point diagram will look different. But the same rules apply. You can always go to 1 atm to find the melting point and boiling point. The curves or the lines will be shifted left, right, up, or down, depending on the substance. So I need you to take some time to practice using a triple point diagram and finding the phase change diagram.